Hello people, welcome to trick 15 quant 45 to 51. Sum of squares equals to 0. That means each of them is equals to 0. And yes, of course, the series is presented to you by Mission MBA. Let's go ahead and have a look at it. This is just gonna slay many of the GMAT questions in just few seconds. Let's go ahead and understand this trick and even the trap, because this thing will be used in DS traps as well. Have a look at the question. Find the value of x if 3x minus 2y square plus 2x plus y minus 7 square equals to 0 and x plus y equals to 5. Now when we gave this question to 100 people, 70 of them without thinking just opened up this equation, and then they were down to such kind of equation: 9x square minus 12xy plus 4y square and so on. Very complicated equation. And now they got stuck. They are trying to put the value of x over here. They're trying to substitute the value of y over here. And finally they left it. So guys, this is not the correct approach. You are just opening this quantity without even analyzing it. My question to you is, you know that this quantity is a square of some number, 3x minus 2y whole square. So it has to be either 0 or it has to be positive. It definitely cannot be negative. Square of a quantity is not negative, either 0 or positive. Similarly, this quantity is either 0 or positive. The negative numbers not allowed. So guys, think and focus. If one of them becomes positive, the other has to become negative to nullify it and get 0. For example, if you have a 2, then you have to subtract something to make it 0. You cannot add something to make it 0. And that's the catch. So, if this quantity cannot be positive, neither this quantity can be positive. And of course, they are not negative. There is only one possibility left, that both of them are 0. There is no other way out that you can make the sum of squares equals to 0. So remember, whenever you're given any entities like this, x square plus y square plus z square equals to 0, they tell you just one thing, and that is x equals to y equals to z equals to 0. There is no other option you can satisfy this. Again guys, remember, this works for the even power only, not with the odd powers. If you have x cube plus y cube plus z cube, you can have x as minus 1, you can have y as 0, and you can have z as 1. Now this will become 0, even the numbers are different, but not such scenarios. If you have even powers and they sum up to 0, you have only one possibility, that each of them is individually 0, because if you make one positive, you have to make one negative, and that's not in your hand. So you have to make all of them individually 0. So down the line, what this question becomes? So I have this square plus this square equals to 0. That means individually they are 0. And once I get to it, I guys have three equations. Very simple. 3x minus 2y is 0. 2x plus y minus 7 equals to 0. And x plus y equals to 5. Simply pick up any of the two which you find easy and go ahead and solve it up. I'm picking up these two because I feel that these two are the simplest one. So I'll multiply it by 3. So I get 3x plus 3y equals to 15. And this one I have as 3x minus 2y equals to 0. I'm going to subtract it. This goes away. This becomes 5y because I'm subtracting it. The sign changes. This becomes 15. So y comes out to be 3. Right? This gets cancelled. Once y is 3, I'm going to place it over here. So y is 3, so x becomes 5 minus 3, that's 2. So I have y as 3 and x as 2. I need to find the value of x. So x is 2. The answer is B. Now, guys, this can also be used in data sufficiency trap. For example, if I say find the value of x, if, I'm changing the question guys, I give you, let's cut down this part, and I give you that first statement is 3x minus 2y whole square plus 2x plus y minus 7 whole square equals to 0. Now many of you might think that we have one equation and two unknowns, x and y. The data will not be sufficient. But guys, you have again made a mistake. In one equation only, you are getting two equations formed. How? This is 0 and this is 0, because sum of squares equals to 0 tells you that individually they are 0. So definitely 3x minus 2y equals to 0 and 2x plus y minus 7 equals to 0. So this data, guys, is sufficient, not insufficient. Within one equation, I have my two equations and two variables. I'll be able to solve it. Alright. So never make a mistake that, okay, sir, I had one equation, two variables, it was insufficient. No, it was sufficient. There were two equations hidden in just one equation. I hope you have got the trap. If not, just rewind the video and watch it again. I'm sure you will get it. The idea is sum of squares equals to 0. That means individually they are equals to 0. Then it's your call that you even include four variables in one equation. And if you give me like this, I'll tell you this one equation is also sufficient to find out all the four variables. And all the four variables are nothing but 0. I hope this is clear. Let us see how GMAT has exploited this and used this trick in various other topics. Let's go ahead and watch. So there was a question in statistics which said, is the standard deviation of the set S greater than 0? Set S contained four elements, A, B, C, and D. Now to answer this question, first we need to know a little about standard deviation. So what is deviation? Deviation is how your numbers are separated from the mean. If your numbers are separated from the mean, then the deviation occurs. If not, then the deviation does not occur. So guys, one thing to note is that standard deviation will either be positive or will be equals to 0. It can never be negative. Why? Simple. If your numbers are deviated, you have some standard deviation. You have deviation. If your numbers are not deviated, you say there is no deviation. Hence it is 0. There is nothing like negative deviation. Either you are deviated from a number or you're not deviated from a number. Be careful that if your mean is 4, you have the number as 5. It is deviated by 1. Even if you have the number 3, it is deviated by 1 again, not minus 1 or 1. This is a set where the numbers are deviated from the mean. But when your standard deviation is going to be 0, there is only one case when your standard deviation becomes 0. And that is when your numbers are not deviated from the mean. And when your numbers will not be deviated from the mean, when they all are equal. For example, if I have four numbers, all are 4, mean will be 4. And hence, my numbers will not be deviated from the mean. Each of them was same, of course. So they will also be equal to the mean. So in that scenarios, deviation becomes 0. But if you have some numbers like 3, 4, 5, the mean becomes 4. This is deviated by 1. This is deviated by 1. You don't say this is by minus 1 and this is by 1 and hence it is 0. No, the numbers are deviated. You cannot say the deviation is 0. The deviation is there. So this case, deviation is positive. But there is no case when deviation is negative. So when he says me, is the standard deviation of the set S greater than 0? He simply asks me, are my numbers different? If my numbers are different, then standard deviation is greater than 0. And if my numbers are equal, then standard deviation is equals to 0, like in this case. So this thing you should know before proceeding to the question. Now let us see how to deal with the question. So, is the standard deviation S greater than 0? Now let's go to the statement. Sum of squares equals to 0. It tells me that A equals to B equals to C equals to D equals to 0. And hence, my all numbers are same. If my all numbers are same, the mean is same as well. Like 0 in this case. Therefore, there is no deviation because all the numbers are equal to the mean and that is equals to 0. So my standard deviation is equals to 0. So this data is sufficient. Second statement says A is not equals to B. And I have told you if any two numbers of set are unequal, then one of them for sure is going to be deviated from the mean. So deviation will occur, and hence your standard deviation will be greater than 0. So this is also sufficient. So the answer is Delhi. If you understood it, perfect. If not, then also it does not matter much, because the trick was not about standard deviation. The trick was about understanding that this first statement meant A equals to B equals to C equals to D. If you find till here, that's absolutely perfect to me, because I was not teaching you standard deviation over here, right? I hope you understood it. Be sure that you subscribe our channel, and if you have any difficulties in quant, you can let us know in the comment section. We'll definitely try to make a video of that as soon as possible. And if you're looking for some doubt clearance, you can also message that to us. The details are given in the description. We'll try to make a video on your doubt and post it over here. Thank you and have a nice day.